In our earlier years, we used to try to visualize numbers on a number line. This number line spanning from negative infinity all the way to positive infinity was good enough for us because our real numbers always lived on one dimension. So if we were asked to solve for all values of x which is less than or equal to 1, we would say that because 1 is being included in this inequality, we will fill it up with we'll have a filled dot and shade everything towards the left of 1. Had it been x is greater than 1, because the 1 is not included, will be an open circle and shading everything to the right of 1. As complex numbers live on a two-dimensional plane, the Argand diagram, we have another degree of freedom, the vertical axis, the imaginary part. Because of this two-dimensional axis, it allows us to separate and partition the entire complex plane in three particular ways. One is the perpendicular bisector, the other one is a circle, and the other one is the argument. So we're going to take a look at these three rather fundamental ways of partitioning the complex plane in this discussion of locuses, the plural being loci. Let's take a look at this perpendicular bisector system. What this is trying to say with the absolute value bars is that the distance that some complex number z is from 2i is the same distance that that same complex number z is from 4. If we were to plot it on the Argand diagram, 2i is somewhere here and 4 is somewhere here. Then the line segment joining 2i to 4 or 4 to 2i is over here. Now, if we were to ask the question, where must z be to be equal distance from 2i and 4, you'd probably be saying that it's going to be the midpoint. And you'll not be wrong. However, this is not the only solution possible. It could be here, because the distance from 4 and the distance from 2i will be the same. But it could also be here, and here, and here, and anywhere along this line. Anywhere along this red line satisfies the locus of this perpendicular bisector system. Now, because this red line is a line, we can extract a y equal mx plus c sort of a thing. Firstly, we need to remember that the absolute value of a complex number is going to be using that. Z is always x plus iy. Clumping out all the reals and imaginaries. Using this identity. Expanding and simplifying. This and this goes off, this and that goes off. Putting all the y's to one side and all the x's to the other side. Simplifying further. And that is the Cartesian equation of the perpendicular bisector, which should fit what we expect because we got a positive gradient and a negative y-intercept. In this case, a positive gradient and a negative y-intercept. Well, obviously not to scale, but a negative y-intercept nonetheless. The next type of loci we can look at is a circle. Firstly, we must always ensure that our locus is always put in the standard form. What do I mean by standard form? We would like to express this as z minus a number. In this case, the number would be 2 plus I. So what this is trying to say is that z from 2 plus I, its radius is always, its distance is always going to be 3. So the only time we can actually get such situation is if it is a circle centered at 2, 1. Because we know that our circles are always x squared plus y squared equal to radius squared, we can indeed do the same thing here using the whole, and because z is always x plus iy, clumping all the real and imaginary together using this. Or if you don't like it to be 9, you can write it as 3 squared. Equivalent. The last locus we're going to look at is the argument. So, the argument in this case is going to be, the angle is going to be equal to pi on 4. Starting from the origin, pi on 4. Now, a good question is, why do we exclude the origin of the origin, or in this case the origin of this arrow? The reason is this: at the origin, what direction are you pointing at? The second form is the argument of a complex number is always going to be equal to the arctangent of the imaginary component divided by the real component. If at the origin, your origin is always 0 plus 0i. What is 0 divided by 0? Indeterminate. So we have to exclude this one singular point.